Hi everyone, so today we're talking about coordinate proofs. So basically you're going to be given coordinate pairs to graph on a grid, and then you have to see what type of shape it is. So for example, is it a parallelogram? Is it specifically a rhombus, a rectangle? What shape is it? And it's not enough just to graph the 4 points and say, well, it looks like a rectangle or it looks like a rhombus. We actually have to use what we know about those shapes to say whether they are or are not a rhombus, a rectangle, whatever it is. So the first thing you have to do is draw this graph and draw the points as well. So do this with me. Okay. All right, and you can actually connect those dots, which I'm going to take a moment and do that with you. And that one didn't quite get to where I wanted it to be. Fix that really fast. Okay. So the next step is that we want to see, well, what are the slopes of these different sides? So we're going to take 1, 1 and 2, 5 and look to see what the slope is. So remember y2 minus y1 over x2 minus x1. Or we can just look at the difference in height. So this height, the difference would be, or the length would be 4. And the run is 1. Or we could just say the slope is 4. Well, if we look at this opposite side, it went up 4 over 1. Once again, if you want to put it into the slope formula where you have y2 minus y1 over x2 minus x1, that also works. Now if we look at, so the opposites, these two opposite sides are parallel. Now let's look at the other two opposite sides. Well, it didn't go up at all, so 0, but it went over 3. Oops. Hopefully your fraction will look a little bit better. And again, on the top, it didn't go up or down at all, so it's 0, but it did go over 3. Okay, so we have the same slope on opposite sides for these two sides as well. Okay, so now we want to know, so it is a parallelogram because opposite sides are parallel. Well, we want to know what the different side lengths are. Well, 2 of the sides are pretty easy to see. So that length is 3, that length is 3, but it's not as easy to tell with these other 2 sides. So we want to look at the distance formula. Okay, so the distance formula, remember, is the square root of the following. Okay, so make sure that you are writing that down if you can't find it right away. So it equals the distance. So we're going to plug in the coordinate pairs. Well, we're looking at 4, 1, so that coordinate pair, and we're looking at 5, 5. So again, take a few moments, do this with me, and I'm sure your square root symbol, your radical, will look a lot better than mine. So it doesn't matter which point we start with, it's still going to be the same distance. So I'm just going to start with that first point in the line. So my x1 minus my x2, or x2 minus x1. It's supposed to be a minus sign, by the way. And then plus our y2 minus our y1 my lines aren't quite straight yet. And we're just going to simplify that. So 5 minus 4 is 1. Well, if we square that, and I'll write it down so that you can see each step, but if you square it, it just becomes 1. And then 5 minus 1 is 4. And if you are able to skip this step of writing this down, that's fine. So 4 squared is 16. So once again, we're going to simplify that to get 1 plus the 16, or just the square root of 17. Okay. Now that is as simplified as you can make it. So this side right here is the square root of 17. Well, let's see if the other side is also the same length. So we're now going to use 1, 1 and 2, 5. So once again, we're going to plug it into this formula. So we're going to take our x1 minus x2, and then y1 minus y2. Extend that a little. Okay, so when we simplify this, so 2 minus 1 is 1. Again, if you can skip this step, if you can already just put 1 as that simplified version, that's fine. And then 5 minus 1 is 4 squared. And hopefully this is looking pretty familiar from up above. Well, if we square that, we have 1. And then square 4, we have 16 to get the square root of 17. So as you can see, this other side is also the square root of 17. So the opposite sides are equal in length, but not all sides are the same. So it can't be a square, it can't be a rhombus, because if you remember from the notes that you took and the information that you were looking at in class, a rhombus, all sides are the same. So even though it is a parallelogram, it can't be a rhombus. And it can't be a square because, again, the square, all sides have to be the same. This would be a parallelogram. So once again, you can't just look at a shape and say, oh, that looks like a rhombus. You can't quite do that because, once again, even though it might look the same each side, it's really not. So when you go to class, keep that in mind. Make sure you're looking for all the details of the drawing that you are creating, and have a good time.